Hello friends, welcome to engineering tutorial. So in the previous video we discussed the basic idea behind addition of vectors and about the triangle law of vector addition, the basic concepts. So in this video we are going to discuss about the parallelogram law of vector addition, the second way of understanding or applying the vector addition that rule. So basically it is the modification, a slight modification of the triangle law. The idea is the same, but there is a slight change in the way we look at things. That's the difference. The basic idea, that is the same. Okay. Let us say we have two forces, okay, or two vector quantities. Okay, the best way is to understand the help of forces acting at a point, but okay, let's say we have two vector quantities. Okay, this is one and this is the other. Let's call it P vector and this as Q vector. Now let us draw a parallelogram out of it. Okay. Another important thing associated with vectors is the concept of shifting of vectors. Okay. One interesting property of vectors is that we can shift the vectors laterally, sidewise, or top to down, or down, bottom to top, top to bottom. What I mean is that suppose we have a vector like this, okay, we can either take it, move it upwards without changing the magnitude and direction, or we can take it downwards without making any change in the magnitude and direction, no change to that. We can shift the position of the vectors either from top to bottom, bottom to top, or laterally and sidewise. Similarly, if we have vector like this, we can shift it either to the right or to the left. Again, the same thing, we cannot change the magnitude and direction. So here, if we shift this vector P upwards, if we shift this vector P upwards, so it will be like this. Okay, and if we shift this Q vector sidewise to the right, then it will be like this. Okay, this is the P vector, this is the Q vector. All we have done is that we have shifted them using the property of shifting of vectors, either from bottom to top, top to bottom, or from left to right or right to left. So we have shifted the P vector upwards, Q vector towards the right. So now we have formed a parallelogram. Okay, the same thing, either the vector quantities like this or like this, they are the same thing. Okay, P vector, Q vector, or P vector, Q vector, they are the same, they mean the same effect will be produced. If we join both of them together, the two systems will form a parallelogram. Just to form the parallelogram, we perform this shifting. So now, according to the parallelogram law of vector addition, if two vector quantities acting simultaneously at a particular point, in this case p vector and q vector, they are represented in terms of their magnitude and direction as the two adjacent sides of a parallelogram. Okay, here p vector and q vector, these two are adjacent sides of a parallelogram, and when we perform the shifting also, these two vectors p vector and q vector, they are also the adjacent side of the parallelogram. So if the two vector quantities are represented as adjacent sides of a parallelogram, then the resultant vector is the diagonal of the parallelogram, okay, the diagonal of the parallelogram passing through the point at which the two vector quantities are acting. Here, this, either this or you represent it in this way, both are the same. This is the resultant vector. Okay, this is the resultant vector. So this is the whole parallelogram law of vector addition. If two vector quantities acting at any given point, they are considered as two adjacent sides of a parallelogram, then the resultant vector of the system is the diagonal of the parallelogram passing through the point at which the two vector quantities are acting. Now here only these things are the same. This is the same idea here as the triangle law. Okay, we can also understand it with the help of the triangle law. If we shift this q vector here, then it will become a triangle, the same as the triangle law of vector addition. But here, just to look at a new way, we made the parallelogram. Okay, but the triangle law is a bit simple to understand. Okay, so this is also there, so we just discussed it. So this is the parallelogram law of vector addition. Okay, the basic idea. So in order to understand the parallelogram law of vector addition in a better way, let us discuss some cases, means the examples. Okay, let us say we have two forces acting, or two vector quantities acting at a certain point. Okay, this is one, this is the other. Okay, at this point. So in order to find the resultant, what we'll do, we'll shift this vector. Okay, let's name it again p vector, this as q vector. So in order to form the parallelogram, we have to perform shifting. So let us shift this q vector, okay, like this to here, and this p vector in this direction. So the resultant will be the diagonal passing through. This will be the resultant. Similarly, if we again have let's say like this, two forces. So again we have to perform shifting. We'll shift this vector in this direction, shift this vector in this direction. This will be the resultant. Okay, let us be a vector, this b vector, shifting, this is the same a vector, this is a b vector. This is the resultant passing, the diagonal of the parallelogram passing through the point of application of the, or the acting of the vector quantities. So this is the whole thing. If we have two system of forces, shift them, form the parallelogram, then the diagonal passing through the point of impact of the two vector quantities or acting point of the two vector quantities, that is the resultant. Okay, so this is the whole idea.